Section 5.4, page 7. All right, for this problem we want to find k so that, oh boy, this integral from a to x of f of t dt plus some k. So that's what we're looking to find. Find that. Equals the integral from b to x of f of t dt for f of x is equal to sine x, where a is 0 and b is 2. All right, so first thing here, let's go ahead and change out the a and the b with these and that function f with sine. So this is now the integral from a 0 to x f of t sine t dt plus k is the integral from b, which is 2 to x of f of t, so sine t dt. Okay, so now be very careful here. I know some of you are going to want to automatically just plug that x in for the t. You cannot plug that x in for the t because you're not doing a derivative. The only time you actually take out this t and plug that x in is if you're doing a derivative of an integral. So we need to figure out some other way to evaluate this. Let's see, could we move that k over to the other side and subtract this so we can get all the x's on one side in the integrals? So let's look at this. The integral from 0 to x of sine t dt minus the integral from 2 to x of sine t dt equals opposite of k. All right, now this is still kind of ugly to deal with. Let's see if we can put a visual with what that is. Our curve is sine t. I'm just going to put the sine function up there. All right, and remembering a few values, this is pi, which is 3.14. Here was pi over 2, approximately 1.57. All right, so this is the area underneath this curve from 0 to some spot x. All right, doesn't matter where you put that x. I kind of want to keep everything positive. So I'm not going to worry about this part down here. I'm going to put my x way out here. And here's why I'm going to choose that. I want it to be bigger than 2. And if that's 1.57, 2 is probably right about there. So I want to be pretty close to pi. So there's some x. All right, this talks about the area from 0 to x. That's this one, area from 0 to x. This second one talks about the area from 2 to x. Well, where's 2? 2 is probably right about there. So that second one talks about that blue area. So looking at this, this says the area from 0 to x, all that original red shaded stuff, minus the area from 2 to x. 2 to x. Oh, isn't that just the area from 0 to 2? Yes. So we can stick these two back together and say that this is the integral from 0 to 2 of sine t dt equals negative k. All right, now again, don't go plugging that 2 in here. You're not doing a derivative. You're not doing a derivative. This is actually a second fundamental theorem because you can evaluate this now. You know how to do this. What's the antiderivative of a sine? That's negative cosine. Negative cosine t, we're going to evaluate that from 0 to 2. That value is the opposite of k, which means we have negative cosine 2 minus negative cosine of 0 comes plus. So this is just cosine 2 plus, because I don't know what that one is. Cosine of 0, you know what that is. That's 1. And I'm just going to flip this around here. Oops, lost my negative. That's 1 minus cosine of 2 is equal to the opposite of k. And if you zap this in your calculator, making sure your calculator is set in radians, this comes out to be 1.416 is the opposite of k. So k is negative 1.416. Done. All right, now you can check this. All right, so we think k is this negative 1.416. So choose any number you want for x. Okay, how about 26? Okay, then if we substitute that 26 back in, here's what we're checking. The integral from, let's see, this was 0 to x, which is 26. I'm just looking back up here at my top line. 0 to 26 of sine t dt plus your k, negative 1.416 approximately. Is that equal to the integral from 2 to x, so 2 to 26 of sine t dt? You have to zap this in your calculator. If you evaluate that integral in your calculator, this piece gives you 0.353 something 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 plus negative 1.416 something something something. Is that equal? And this piece is negative 1.063. And when you combine these guys together in their entire decimals, you will get it matches. As long as you use the whole big long decimal, you will get these to be exactly the same. If you round it off here, here, and here, they're going to be very close. Very close.